Everybody, welcome back. In this video, what I want to do is go over the notion of a constructive dilemma. When we get to the more advanced rules, there also is something called a destructive dilemma, but at this point, this is all we need to worry about. It's also called or out. Now, I want to be very clear on this point because this is an area where I've seen a lot of students make this mistake, and I mentioned a little bit in the last video that, like, if you've got a conjunction like A and B, with and out, you can just break those things apart. Okay, if we got A and B, I can get A and B separately. If you got A or B, or out is not this. It is not, oh, I've got A or B, I can just break those apart. Nope, that is not what it is at all. You can never just break apart disjuncts. Conjuncts? Sure. Now, since they both have to be true, for a conjunction to be true, both of its parts have to be true. Both of its conjuncts have to be true, which means if you break it apart, you know definitely that the individual parts are going to be true. But with disjunctions, since only all a disjunct requires to be true is at least one part being true, you don't know when you break them if the disjuncts themselves will be true. In fact, if it's an exclusive disjunction, there's no way you can do that because only one of them can be true, even if you don't know which one it is. So, or out is not breaking apart a disjunct. It's more of a process. Now, fortunately, it's not merely a situational process. You can look exactly at the examples that I have here. Now, there's two kinds of constructive dilemmas. One where the conclusion is redundant, and one where you've got a conclusion that is a disjunction of separate cases. Sometimes it's called proof by cases. I don't like to distinguish them. They're both or out. Just one is where the conclusion is the same thing in either case. So let's take a look at these examples. So let's start, the redundant one is the most simple. So let's consider this. Like, let's say we're coming to the end of the semester and you think you're either going to get a C or a D in the class. Okay, well, let's make it even more down. Let's say, not for this class, but let's say you're going to make a D or an F. And if you make a D or an F, and let's say it's something from your major, you'll have to take it again. So let's say A stands for, I make an F. And let's say B stands for I make a D. And I'm going to use this for this example of a redundant dilemma. And let's say C stands for I'll have to retake it. I'll have to retake the class. Well, let's read this out then. Here's the way a redundant dilemma looks, or an or out. The conclusion is the same. You could say, with those values, if I read this out loud, I would say, I'm either going to make an F or I'm going to make a D in this class. If I make an F, then I'll have to retake it. If I make a D, I'll have to retake it. So, no matter what happens, I'm going to have to retake it. Now, there's a way in which you could say, technically what's going on here is, because of this, make an F or I make a D. If I make an F, then I'm going to have to retake it. If I make a D, I have to retake it. Really what's going on is I'm going to have to retake it, or I'm going to have to retake it. That's what we call in logic a tautology. Anything or itself, also anything and itself is a tautology. Like I said, this marker is a marker. I didn't tell you anything you already didn't know. It just refers back to it. So instead of doing that, we can simply say, hey, if you got like a choice situation, and here's what's going on here. One of these two things is happening. If this thing happens, here's the result. If this thing happens, here's the result. So this is going to be the result no matter what. That's what's going on in this situation in an or out. Now, this is what we got out of it. This is an or out, not breaking apart A or B. Basically, here's the technical way to understand it. You got a disjunction. Anytime you have an or statement, look and see, are the disjuncts, the or parts, are they on the left sides of some arrows? Yep. And if they're on the left sides of some arrows, then you can stick the right sides together as a disjunction. And if they're the same thing, you can just say that thing. So let's take a look at the example where it's not redundant. So let's say something like this. Instead of I make an F and I make a D, let's say it's, well, let's keep it the same. Let's say, let's make D here. I'll graduate. Yay. So here now, I make an F is A, B is I'll make a D, C is I'll have to retake it. That's in the case that you make an F, and D is I will in fact graduate. If I make that D, in this case D is getting degrees. What's happening here? Well, I'm either going to make in this scenario, I'm either going to make an F or I'm going to make a D. If I make an F, I'll have to retake the class. If I make it D, I will be able to graduate. So result, either I'm going to have to retake or I'm going to graduate. One of those two things is happening. And here's the diagram of this. You got this choice. If this thing happens, here's going to be the result. If this thing happens, here's going to be the result. So one of these two things is resulting. So one of these choices, if either one of these is true, then if we can say that this is a true disjunction, one of these things is going to happen, and one of these things is going to be the result. And here, it just happens to be that it's not the same result in either case. Here, it's different results. Okay, so this is an or out where there's individual cases going on. But it's really the same thing. Here, it's just redundant. Brief note about XORs here. You could have XORs in the premises here, okay, A or B, but not both, because you're not going to make, and I think actually that's more fair. It's the case that you can't make both an F and a D. You're going to have to get one or the other. But it still might be the case that you'll retake and eventually graduate, and that not be a not both. So you can, I'll just say this, you can never get in the conclusion an XOR. That could never, ever, ever happen. So even if it were this, with an XOR in one of the premises, you'd still get an inclusive OR out of it. Same thing here. If we said we could get an XOR out of it, think how ridiculous this is. C or C, but not both. That's ridiculous. So I'll just say this, with OR out, with a constructive dilemma, you could have the disjunction in the premises be inclusive or exclusive, but your resulting conclusion, if it's in the proof by cases one, could never, ever, ever be an exclusive. You can only get a regular inclusive OR out. There's no such thing as an XOR out.